Hi, this is Ms. Kierstead. We're going to do a little video today to get you started on sequences. This should be somewhat familiar, maybe a little bit of new. We are going to start. I'm going to have you pause the video right away, which seems silly, but there you go, and read this little blurb from our book. So hopefully you got this, that in nature, we're looking for sequences. Just like yesterday, you tried to take a picture of a sequence somewhere in your house or a pattern. It could be numerical, it could be other things. So this, maybe you could take a picture of a sunflower because there are patterns in the sunflower, and what scientists have figured out is that the spirals follow these patterns depending on the type of sunflower. But the numbers that show up come from this famous, probably one of the most famous sequences called the Fibonacci sequence, which is given at the bottom, the 1, 1, 2, 3, 5. If you know, can you see, figure out what that pattern is? That's one of the things we're going to do in this unit is here's some numbers that follow a pattern. What is the pattern? How can we represent that pattern? And we're going to find two different ways to represent patterns called recursive and explicit. So those are our learning targets today. We're going to start our journey into figuring out ways to represent a sequence of numbers explicitly or recursively. So what is the difference in those two things? So when we're talking about a sequence, the input, so the domain, is all the natural numbers n, which means we're not putting in 2.3. And here we're saying n is 1, 2, 3, 4. Sometimes people will start with n equals 0, which is not actually a natural number, but you get the idea. So, but it's the whole numbers and the whole positive numbers. So we're not going to put in decimals. We're not going to put in irrational numbers. We're going to put in whole numbers and get answers out. And besides that, we can talk about them as being explicit or recursive formulas. So on the left there, that explicit formula, a of n, so a given number, like the a sub 1 would be the first term in our sequence. A sub 2 would be the second number in our sequence. A sub 3 would be the third number in our sequence. Then you would plug in that term number. So a sub 1 would be what I get when I plug in 1. And that's one way to think of it. It's pretty, you follow the rule, you put in the number, you get the number out. Recursively is a little different. We are given a starting number, or sometimes starting numbers, the first number in our sequence, or the first several numbers in our sequence. And then we build following numbers based off some formula using the numbers that we have already, some of the numbers that we have already. So here's our two things. The next slide, we are going to, I'm just going to clone this real quick. Okay, so how do we do this? So we're going to say, for example, I can look here and I say when n is 1, a sub 1 would be 2 times 1 minus 1. So the first number in my sequence is 2 minus 1, which is 1. The second number, I'm going to put in 2. And so I'm going to have a sub 2 is 2 times 2, which is 4, minus 1 is 3. Right? So this was my a sub 1. This is my a sub 2. A sub 3 would be what I get when I put 3 in, which would be 2 times 3 is 6, minus 1 is 5. And those are the first three terms. And again, I just plug in my number and I get my output. Recursive is a little different. So we're going to start, I already know that, I already know the first number in my sequence, and that is 1. So 1 is my very first number. Now here I have a rule to find the next number. To find the second number, I take, so to find a2, I'm going to take a of 2 minus 1, in other words, a1, and I'm going to add 2 to that number. So since a1 right here was 1, a2 is 1 plus 2, or 3. To find the next number, right, when I want to find a3, I'm going to take a3 minus 1, which is a2, and add 2. So I'm taking this 3, really I'm going to add 2 to that, and I'm going to get 5. So you notice we came up with the very same list of numbers. These are two different formulas to represent the same sequence. So we can also think about the difference between sequences and what we call function. So our sequence is just the discrete numbers of 1, 3, 5. You can see them right here on our thing. Right here is our 1, and then when n is 2, we get 3, and when n is 3, we get 5, and so forth. And it is just those numbers. When we are doing functions, we can put any input we want here for x, right? We can put anything we want for x, and we can get all the numbers out. But it's the difference between what's called the continuous. So over here we have what's called a continuous function. It's continuous. Functions can be continuous. And then this is what we call discrete. Oops, see. You have to excuse I'm learning how to use this new technology, and my writing with my finger is not as good. So let's do a little practice. We're going to find the first 3 terms of each sequence. So first I want you to think, are these given explicitly or recursively? So when I look at these, do I just put n in and get a number out, or do I have to create the list and use the number before to get the next number? These are both given what we call recursive or explicitly. So for the first sequence, I will start with n is 1. And there will be times when you will start with n is 0 if we want a starting number sometimes, but in most of what we're going to do, we will start with the first term is when n is 1. And that's different also than our starting point. Often when we're doing function mode, our start is at time 0 or initially, but sometimes it could be at 1. So when n is 1 on the first one, we have 1/2 to the 1 minus 2 power, which is 1/2 to the -1 power. And if you remember your powers of exponents, that is going to flip our thing, and we get our first number is 2. Okay, and let's try the next one. The next term is what we get when n is 2. So a2 is going to be 1/2 to the 2 minus 2 power, or 1/2 to the 0. Anything to the 0 power is 1. And then we can, oops, and I don't know why it's doing this. Okay, this is kind of weird. Do I have to erase from here? Let's try that. Ooh, okay. See, new technology. So I have my lists. So I have my numbers. The first number I have is 2. Down here I had 2, and then I have 1. The next number when n is 3, I will do 3 minus 2 as my power. 1/2 to the 1 power is 1/2, and there's my first 3 terms. Why don't you try the next one? The sequence will have more terms, so there's sort of, we can do a dot, dot, dot. It would keep going forever as high as we wanted. Let's look at the next one. So I have the first term that I get is when n is 1, I'm going to do -1 to the 1 power, and then I'm going to do 10 basically to the 0 power, because 1 minus 1. And so I'm going to get -1. The second term, I'm going to have -1 squared, which is going to make that a positive answer. So I'm going to have, let's see right here, -1 squared, and then I'm going to do 10 to the 1 power. So I'm going to have a positive 1 times 10, and I get 10. When I go n is 3, the -1 cubed, I'm back to a negative number in front, and it's going to be 10 squared, so I'm going to get -100. Okay, so those are some explicit ones. And this is one more explicit one. Okay, so if you want to try this, when n is 1, again, so this is one last explicit one. When n is 1, we will have 1 minus 1 over 1 plus 1. That becomes 0. So that's the first term in our list. When n is 2, we have 2 minus 1 over 2 plus 1. So that is 1 over 3, which is 1/3. And then let's try one more. When n is 3, we will do 3 minus 1 over 3 plus 1. And we're going to get 2/4, otherwise known as 1/2. So I think we're going to stop here on this video. I'll look for the next video, which we will do some recursive ones, because I think you're probably more familiar with the explicit formula and how to get outputs from an explicit formula than for a recursive one. So I'm going to stop here, and then you can look for the next video.